Hello everyone, welcome in the fourth part of my online course Microservices with Spring Boot and Spring Cloud. Today we'll talk about API Gateway. This popular microservices pattern is implemented in Spring Cloud Gateway project. Spring Cloud Gateway is currently second the most popular Spring Cloud project just after Spring Cloud Netflix. But opposite to Spring Cloud Netflix, it is not a collection of several independent projects like support for Ribbon, Tool or Eureka. This project provides an implementation of API Gateway that is responsible for hiding the complexity of microservices-based environment from an external client and effectively routing requests to downstream services. It also provides mechanisms for security, resiliency, monitoring, and metrics. Spring Cloud Gateway is built on top of Reactive Framework Netty and Spring Web Flux project. You may enable most of its features in configuration. The basic element of that configuration is a route. Each route is identified by its unique ID, a destination URI, a collection of predicates and filters. A route is matched if the result of predicate execution is true. Predicate is responsible for matching request to the route. After matching, each request or response may be modified by gateway filters assigned to the route. And here is our plan of presentation. We'll begin from the basics, where I'll show you how to create a gateway and configure a simple route with a single predicate and filter. Our gateway will be integrated with Eureka Discovery. After basic sample, we will proceed to more advanced topic. I'll show you how to enable requests rate meeting using Redis. We'll also include and test a circuit breaker and fallback in communication with downstream services. There will be also a short presentation of Actuator endpoints provided by Spring Cloud Gateway. The same as with Spring Cloud Config Server or Eureka Server, our API Gateway is just a simple Spring Boot application that includes and uses Spring Cloud Gateway library. So, to enable it, we just need to include the right starter to Maven dependencies. It is Spring Cloud Starter Gateway. Because our gateway needs to be integrated with Discovery Server, we need to enable that feature in configuration properties, and then include Spring Cloud Netflix Eureka Client Starter in Maven dependencies. After that, we may start our gateway, but first it is required to have running instance of Eureka and 2 sample microservices listening on dynamically generated ports. That's why we have to change settings of intercaller service application by defining special profile gateway used just for testing the current scenario. In the previous part of our tutorial, intercaller service was listening on port 8080, which is now reserved for our gateway. After all required changes we were restarted intercaller service, we may verify the current status of registration in Eureka Web UI. You see that there are 2 services registered there, intercaller service and intercall.me service. And the next step is of course to run our gateway application. Our gateway is using Netty as visible in the logs and is listening on port 8080. We may send some test requests. Post endpoint, and as you see, we need to use a service ID in uppercase pattern. That's why Eureka using uppercase pattern in service registration. So it is auto-configured in our route too. We may call some other endpoints like get that returns a high story. We can change the default behavior of a gateway and use a lowercase pattern in service ID. We just need to use a lowercase service ID property in application properties. We'll also disable default ribbon client for load balancing between existing instances of application. As you see, it is still used by default on the gateway, the same as for inter-service communication, we need to disable it to use a Spring Cloud load balancer. After the changes, we are restarting our application. We may now send some test requests once again. Now you see that we are changing this uppercase pattern to lowercase pattern, and still everything works fine after changes. Now let's take a look on the logs to ensure that a ribbon client is not used for load balancing. You see there is no ribbon logs in the from the communication, and Spring Cloud Load Balancer is currently used as a default load balancer. Okay, until now we are using auto-configured behavior of Spring Cloud Gateway of resolving URLs taken from discovery. Let's imagine we would like to change the paths exposed in the gateway for routing stream services and replace there the full service ID taken from discovery with a shorter version. We'll also add API prefix to each exposed URI. Those changes are enabled to apply without providing configuration of every route, so you need to first define the predicates. We'll use a path predicate. This path predicate is an API call me. We are also setting filters. We've got around 30 filters available on Spring Cloud Gateway for configuration. We'll use here a strip prefix gateway filter and rewrite path gateway filter. Both these filters can be used for changing path when sending a request to the downstream services. So we are starting from rewrite path. As you see, everything what is after API prefix is stored in the path variable, and then it's rewritten to the path variable. So we are cutting an API prefix from path. You can also define a route for the second service. It is intercaller service. We use an LB pattern in URI. We are also defining a path predicate, which is API caller, and we are adding a strip prefix filter. It removes API prefix from the path when forwarding this request to the service. In fact, it's the whole required configuration. We can restart our application and perform some test requests once again. As you see, all predicates are displayed in the logs. Okay, now we are using API call me call path to call the application. You can compare it to the previous call where we were using a service ID from discovery. Now it is more simple. We also need to set a JSON and content type. You see that everything works fine. Here we are sending the same request for caller. It is using a strip prefix, so it's different behavior, but it is doing the same thing. Everything works fine, and that's what we want to achieve. Our next topic is rate limiting. A rate limiter may be defined as a way of control the rate of traffic sent or received on the network. We can also define a few types of rate limiting. Spring Cloud Gateway currently provides request rate limiter, which is responsible for restrict each user to receive only configured maximum number of requests per second. When using request rate limiter with Spring Cloud Gateway, we may leverage Redis. To do that, we first need to add a reactive client library for integration with Redis. In the next step, we are adding a filter responsible for enabling rate limiter for the route. Its name is request rate limiter. It takes two parameters, replenish rate and burst capacity. The replenish rate decides how many requests per second a user is allowed to send without any dropped request. The second property, burst capacity, is defining the maximum number of requests a user is allowed to do in a single second. We can also override a default value of key resolver. A key resolver is used for identifying requests for late limiting, and by default it is an authenticated user principal name. We will just change it to the static value for simplification, what means that every incoming request is used for counting a current limit for number of allowed requests for rate limiting. In the next step, we need to run Redis container. We are using the newest version of Redis, which is 5.09, and we are exposing Redis on port 6379. We can take a look on container logs to verify if everything works fine on the container. You see that it was started. And now we need to override a default Redis address, which is not localhost, but is address of my virtual machine with Docker. And in fact, it's a whole configuration required for enabling rate limiter in Spring Cloud Gateway. We just need to restart our application. And now we will print details of request. With a curl command, you see that there are 4 new headers returned in the response. The most important here is X-rate limit remaining, which indicates number of remaining requests we can send in within the next 1 second. It also returns current values of parameters. So now we are sending 100 requests in a row, and you see that value of X-rate limit remaining is changing during the time. It has different values, but now we need to generate much more requests to achieve too many request exception. As you see, if there is no ability to process a request on the gateway, it is returning HTTP code 429 as a response, and so the next topic is metrics and monitoring with Spring Boot Actuator. First, we are going to expose all the Actuator endpoints available for our application, and we'll also print details in health check endpoint. You see that gateway metrics are just a global filter, and we need to add Actuator to enable it. We don't have to do anything else. It's the same with load balancer client. It's also a global filter, and we're just enabling it by defining LB prefix in URI. After enabling all Actuator endpoints, we just need to restart the application. You see that it's exposing 18 endpoints outside. Now we're going to verify health check endpoint. You see that there are pretty many details about it, like discovery client, disk space, and also integration with Redis. You see that its status is up and current version is 5.09. In the next step, we take a look on the all Actuator endpoints returned by the gateway. Most interesting for us are 2 endpoints. First of them is metrics, and to check this endpoint, we'll send many requests to the call me service into the caller service. Now we can verify the gateway requests metrics. It is returning such important information as total number of requests received by the gateway and total processing time. It is tagged with HTTP status codes and root ID. We may refresh the value of our endpoint and see that a new request has been processed by the gateway. Spring Cloud Gateway also provides a special API for managing and monitoring gateway. You see that, for example, we may call endpoint gateway routes, which prints a list of all existing routes in our application. You see that there are still routes taken from Discovery server directly. Here is the list of all endpoints. For example, we may add a new route or remove existing route. We may display the list of all routes. We may display global filters and some other things using this API. So I think it's very usable in some cases. The last topic in this part is a circuit breaker with resilience for J. We have already used it for inter-service communication in our application intercaller service. And the same as for intercaller service, we need to first add the right starter. But this time it is a starter for reactive version of circuit breaker, since we are running our gateway on reactive framework netty. So we are using a circuit breaker reactor resilience for J starter. Then we need to define a bin that customizes the behavior of circuit breaker. We can, for example, copy it from intercaller service application and paste here in the gateway. We just need to change one thing. Instead of resilience for J circuit breaker factory, we are using a reactive version of this factory. And we can leave the same settings or change them. It's not very important, but it's important to change the timeout, the default sliding window size, and slow core rate. Because we already have a defined circuit breaker for intercaller service in communication with intercall service, now we'll just add this circuit breaker filter only to the intercall service route. The name of our filter is circuit breaker. Only one parameter is required. It is the name of circuit breaker filter, and we did to sample slow circuit breaker. We can also use a parameter for setting fallback URI. Circuit breaker is returning a response from fallback if something goes wrong in communication between services. Our URL is fallback test. Now we are proceeding to defining a controller for handling fallback. It's defined in controller package. We are creating a fallback controller class. The implementation of fallback endpoint is very simple. We are just returning a call me response that have a static ID and message like I'm fallback. We are creating a single post endpoint. It can return a reactive response as well. We can just return a mono interface, mono object instead of a gateway response. Now we need to run a second instance of intercall service application. We are going to enable random delay presented in the previous part of the tutorial. It adds a random delay to the endpoint between 0 and 2 seconds. And after that, we are starting a second instance of call me service. Now we have two instances of call me service. First is not delayed, while the second is delayed with a value between 0 and 2. You see in Eureka Web UI that there are two running instances of call me service. Thanks to that, we are able to test our circuit breaker. You see that if it is not able to communicate with the service, it enables fallback. You see that some request has been sent to the delayed instance of call me service. Some of them were sent to not delayed instance. Now we need to send many requests in a row. We are sending 100 requests to the call me random endpoint, and you see that after some time it is just enabling fallback. It means that a circuit breaker has been opened. Number of timeouted requests has been higher than a threshold, so the circuit breaker has been opened. Before the test, I changed a little settings of a circuit breaker. I changed the slow rate threshold into 33 and .3. It means that if more than one if-free request is finishing with timeout in the given period of time defined in sliding window, the circuit breaker is open. With this part of my tutorial, I'm finishing with introduction to building microservices architecture that communicates over HTTP protocol. So thank you for attending this course. In the next parts, we will discuss message-driven microservices built with Spring Cloud Stream, and we'll also discuss some topics related to testing microservices.